Welcome back to the deep dive. Today, we're not just, looking at security footage. We are doing a real forensic statistical breakdown of surveillance and labor tracking data. You're
Right.
taking 65 different incidents, and this is everything from standard security flags to some pretty intense internal labor tracking. And we're asking one single sharp question. What actually defines, and maybe more importantly, what predicts risk?
And that's really the mission here. It required a very deep dive into the numbers. We're not going with gut feelings on this one.
No, not at all.
The report we're trying to break down today is built on some pretty advanced stats. Correlation to find the links, progression to build predictive models, and then something called factor analysis to really decode these complex behaviors into simpler ideas.
And the goal is to find the absolute shortest path to identifying what the report calls a threat symptom.
Or pattern yellow, exactly.
The stakes feel really high here because the central tension in all this data is figuring out what security should even be paying attention to. You have limited resources, so which signal matters most? Is it the when, the time of day? Is it the where, the location?
Or to who, the subject's identity.
That's the core puzzle we're trying to solve. Okay, so let's unpack this. I think we should start with the basics. Time and space.
Makes sense. When analysts first look at this kind of data, the first thing they do is look for hotspots. And, the correlations are there. It confirms what you'd expect.
Common sense, right?
Exactly. You see a ton of activity at the main choke points. The vehicle parking gate, the main entry gates. No surprises there.
And that activity lines up with the daily rhythm of the place. You have the evening surge when people are leaving, deliveries are showing up, and then that midday monitoring window. More traffic, more incidents. It seems simple. Location plus traffic equals risk.
It does seem simple, but the analysis very quickly showed that the time element, it carries way more predictive weight than just the physical location by itself. The data showed what they call a shift risk dependency. So if you take all the serious incidents, the ones called pattern yellow, they're just overwhelmingly packed into these very specific threat windows.
And what time are we talking about here?
We're talking, crucially, between 1500 and 1700.
3 to 5 p.m.
3 to 5 p.m. That 2-hour window is where the probability of a serious security event just wakened.
Right.
It skyrockets. And it doesn't matter which gate or which part of the facility you're looking at.
And this is where we get past just simple correlation, right? We're looking at the regression model now, which can isolate these factors and test them. It's asking, okay, which one actually matters more?
Yes. And the model was crystal clear. It found that the timing of an observation, the shift alignment, as they call it, is the single most statistically significant temporal predictor of a threat.
How significant are we talking?
Well, if you look at the raw stats, the probability that this is just a random fluke, the p-value was around 0.09. In this kind of work, that's a very, very clear signal. It tells us time isn't just a backdrop, it's an active driver of risk.
So, okay, if the location is a constant and time is the variable is actually more powerful here. Can we put a number on that? How much more powerful?
We can actually, with a lot of precision. They use something called log odds, which is just a way to measure the change in probability. And any observation log during that afternoon threat window, so 3 to 5 p.m., it increases the log odds of that incident being flagged as pattern yellow by almost a third.
A third, so nearly 32%.
Nearly 32% higher than any other time of day. It's a huge vulnerability, all tied to the clock.
That's incredible. It means a security guard looking at a monitor at, say, 2:50 p.m. and then again at 3:00 p.m., the level of concern they should have about the same odd behavior should jump by a third just because 10 minutes have passed.
It really shifts the focus from, constant general vigilance to targeted timed vigilance. Okay. But that brings us to the next problem. Even inside that 3 to 5 window, most of what you see is normal. Most people are just going about their day. So if time narrows the search, you still have to figure out how to spot the actual threat inside that narrow window. You have to decode the behavior itself.
Which is the perfect segue to the next part of this. The report took more than 15 different behavioral markers, things like, loitering or camera avoidance, and used factor analysis to simplify them, to group them.
Yeah, you can think of factor analysis as finding the main themes in a really complicated book. You go from 15 pages of messy notes to just 3 core chapters that describe what the threat looks like.
So it's chapter 1. What's the most common type of threat behavior?
That would be factor 1, surveillance synchronicity.
Okay, what does that mean?
It's a category for subjects who are clearly actively aware of the monitoring system. We're talking about movement that is synced up with environmental triggers.
Like what?
Like a car pulling over at the exact moment A camera starts its automated pan away from that spot. Or just deliberate actions to stay out of the field of view of a camera you know is fixed.
So the system is catching people who are actively trying to beat the system, the shadow dancers.
Yeah.
It's an assessment of intent.
Yeah, absolutely is.
Yeah.
Factor 1 subjects are trying to be invisible. Now, you can contrast that with the second factor, which is pretty much the complete opposite.
And that would be
Factor 2, asset reconnaissance. This isn't about avoiding being seen. It's about focused looking. It's marked by really specific physical cues.
like staring.
Exactly. Sustained, fixed gazing at sensitive equipment, at infrastructure. The person is systematically scanning the perimeter, often without moving their feet very much. They're just taking it all in.
They're mapping out the vulnerabilities, cataloging assets. And we should point out here, the report notes that the few but very severe labor-related incidents, they averaged a 3.71 out of 5 on severity.
A very high number.
And they were specifically characterized by this factor 2 behavior.
That's a critical connection. Those specific labor incidents were all driven by fixed gazing and asset tracking, and they were almost all happening at Vehicle Gate 1. It shows that when routine personnel are involved in a serious incident, it shows up as this dedicated, focused reconnaissance.
It's a specific pattern for a specific kind of risk. Okay,
Yeah.
so that leaves the third factor, which to me sounds like the hardest one to spot.
Factor 3, operational probing. This is the really tricky one. It's behavior that tries to look routine to hide what it's really doing.
How so?
It's things like unusual stops in places you wouldn't normally stop, or a slow-moving vehicle that's maybe using a delivery code, but its speed and its path are just statistically weird for that kind of delivery.
So they're not hiding from the cameras like factor 1, and they're not obviously scanning assets like factor 2. They're just trying to look like a slightly confused or slow delivery driver.
Precisely. They're trying to blend in by looking normal but flawed. But the model knows what actual normal looks like, down to the kilometer per hour, and that tiny deviation is enough to flag it as probing, as testing the system's response.
So we've got when the risk is highest, and we have how the threat behaves. But now we have to talk about the finding that, honestly, it kind of overshadows everything else we've just discussed. The one factor that just blew the whole model open.
Right. We've said that time, or shift alignment, is the most statistically significant single predictor. But significant just tells you that a factor isn't random. It doesn't tell you how much of the risk it actually explains.
And this is where the subject code just walks in and takes over.
Completely. The identity, or rather the digital category that a person is assigned to. That turns out to be the ultimate driver of risk.
The predictive model confirmed it. The primary subject code is the single most important factor in deciding the final risk level. It's less about what you're doing and much more about what you're labeled as.
Let's put the numbers out there because this is really the core insight of the whole deep dive.
Please do.
The subject code accounts for a massive 45.8% of the variance in risk levels.
Almost half.
Almost half of the entire explanation. Now, compare that to the other factors we just spent all this time on. Time of day. That was only 30.5%. And location, just 23.5%.
Wow. So identity is more important than time and location combined.
By a significant margin, the priority becomes crystal clear. If you want to get ahead of a threat, you have to prioritize identification first.
That is just, it's a profound finding. It means your security system is better off knowing who is coming to the gate than knowing that it's 3 p.m. and they're at the main gate.
And this dominance leads to the most startling finding in the entire report.
Yeah.
What they call the high-risk identity clusters.
Okay.
The data found specific subject codes that had a 100% correlation with threat pattern behaviors. 100%. Every single time one of these codes was logged, the observation escalated to pattern yellow. Didn't matter where they were or what time it was.
It's an absolute guarantee of risk that's just baked into their classification. So who are they? What are these identity clusters?
They're very specific. Real estate tracker agents, say TI, a tenant tracker, face tracker disabled, and maybe the most surprisingly specific one, service delivery fish vendor woman.
Wait, the fish vendor woman? The fact that a specific service role is in there with a 100% threat correlation, that shows just how hyper-specific this historical tracking has become.
It does. It suggests that over time, that one identifier has been consistently linked to high-risk behaviors. It's a pattern the system has learned, and it will not ignore it. The model doesn't care about the job title, just the recurring data linked to that ID.
So you contrast those guaranteed risks with what the report calls routine profiles.
Right, the codes you see all the time without any issue. Things like housekeeping or migrant labor.
Okay.
Those profiles are almost always logged as standard log, observation and movement. Their presence is normal, risk is low, but, and this is a key point, their risk can go up, but it only happens based on location.
So if they're spotted somewhere they shouldn't be.
Exactly. Deep within the sidewall compound or the back compound, places that aren't part of their normal route.
So the high-risk codes, they carry their risk with them, like a backpack, everywhere they go. But the routine codes only become risky if they wander off the path.
That's a perfect way to put it. And the spatial data backs that up. The high-tech, high-risk codes, face, and vetch trackers, they're all logged at the main gates where people are trying to get in. The routine codes, like housekeeping, they're spread out across the peripheral areas, confirming their normal operational roles.
Okay, so we have the full picture now. Risk is driven by who you are, it's triggered at specific times, and it shows up as these focused behavioral probes.
Yeah.
So what does this mean for the security team on the ground? What are the actual strategic takeaways here?
Well, the main takeaway is all about resource optimization. It's about using those second and third strongest predictors, location and shift smarter. The recommendation is to stop spreading your specialized surveillance evenly. Concentrate it. Put your high-precision systems, your best trackers, at the parking and entry gates, but only during those vulnerable windows, that 15:00 to 17:00 slot, and the evening surge right after it from 17:00 to 19:00.
It's moving from just defensive patrolling to setting up targeted ambushes based on the data. And the analysis gives two very specific recommendations. What's the first one, the one tied to identity?
That's identity-based alerting. Since we know those subject codes are such a powerful, guaranteed predictor, the recommendation is to set up immediate, automated supervisor alerts. The second one of those 100% correlation codes is identified.
So the real estate or tenant trackers?
Exactly. You don't wait to see what they do. You don't need an observation period. The alert gets top priority just because of the risk profile of the category itself.
The system is basically treating the identification as the evidence. You are, statistically speaking, guilty until proven innocent. What's the second recommendation?
That's temporal hardening. It means you physically strengthen the gate controls during that evening surge from 5 to 7 p.m. While the 3 to 5 window is where the pattern yellow incidents cluster, the regression models show that the surge hours right after are when non-routine behaviors are most likely to actually happen.
So that's when you put more people and stronger checks at the gate.
That's the idea. Target the peak activity window with physical resources.
The whole report is really a guide to high-precision identification. It's saying that because the subject code explains so much, the moment someone is identified as, say, a real estate tracker, the high statistical probability of a threat is already confirmed. You don't need to wait for them to start looking around.
The system has learned that the label isn't just a label. It's the first piece of evidence of the threat symptom itself.
So what does this all mean for you, our listener? We've seen how statistical analysis can turn all this raw, messy surveillance data into really clear, actionable insights. It proves that, in this context anyway, that the category you belong to, your subject code, has way more predictive power than where you are or what time it is. The who just completely dominates the when and the where.
And that shift in thinking, it forces you to reconsider the very basics of security. If the model proves that certain identities statistically represent the highest likelihood of a threat, so much so that they're flagged instantly, what does that reliance on predictive categories mean for just, standard observation?
That's a great question.
What happens to the whole framework of security when a person's behavior is statistically defined by their identity, rather than by a specific action you can see in real time? Does the category itself just become the definition of the threat?
Food for thought. We will leave you to mull that one over. Until next time on The Deep Dive.